आधे घंटे के लिए मैं 2 घंटे की क्लास
सर डिस्क्रिप्टिव मेजर तक बताया है।
बस मतलब हम लोग आज जगह ही
सर डिस्क्रिप्टिव मेजर तक बताया आपने अभी।
ओके तो आज हम शुरू करते हैं एक डिस्क्रिप्टिव मेजर which is known as okay, so let us start with requisite of ideal measure of central tendency. Basically, what is central tendency? So it is also known as averages. So averages are, what are averages? Statistical constant which enable us to comprehend in a single effort the significance of the whole. Okay, so this is basically the meaning of average, and this gives an idea about the concentration in the part of distribution. Okay, please wait for 2 minutes. Central part of the distribution. Statistical series is the value of variable which is the representative of which is the representative of entire distribution. Okay. Okay, next, some of the measure of central.
सर इन द सेंट्रल पार्ट ऑफ क्या लिखा आपने वो?
In the central part of distribution. Okay, this is okay. Some measure of central tendency are arithmetic mean, or simply called simple mean. Second one is median. Third one is mode. Fourth one is geometric mean. Fifth one is harmonic mean. These are some measures of central tendency. Next is requisite of requisite. क्या? हेलो हेलो
यस
हाँ बोलिए अनुज, कुछ बोल रहे थे कुछ?
सर समझ नहीं आ सकता।
देखिए ये सारे मेजर ऑफ सेंट्रल टेंडेंसी हैं। जैसे कोई डेटा, यदि आप एक डेटा सेट को देखें, किसी डेटा सेट को, तो डेटा सेट क्या होता है? डेटा सेट एक डिस्ट्रीब्यूशन के फॉर्म में होता है। कुछ वैल्यूज रहेंगी, जैसे सपोज करो 0 to 10 के बीच में सम वैल्यूज रहेंगी, कुछ 10 to 20 के बीच में रहेंगी। सिंपल एग्जांपल, यदि एज का कुछ लोगों, हम 1000 लोगों का एज यदि लें, तो क्या होगा कि 0 से 10 के बीच में कुछ की एज रहेगी, 10 से 20 के बीच में कुछ लोगों की एज रहेगी, फिर 20 to 30 के बीच में कुछ लोगों की एज रहेगी, फिर 30 to 40 के बीच में कुछ लोगों की एज रहेगी, इसी तरह 40 to 50 के बीच में एज रहेगी, और इसी तरह से इंटरवल आपका हो सकता है कि लास्ट हम करें कि 100 से लेके ग्रेटर देन 100 के बीच कुछ लोगों की एज रहेगी। ठीक है, तो इसको सपोज कीजिए FP, इसको डिनोट करते हैं। तो ये जो सिस्टम है, इसी सिस्टम को हम लोग डिस्ट्रीब्यूशन कहते हैं, कि किस तरह से आपका एज जो है ये डिस्ट्रीब्यूटेड है। ठीक है, और इस डिस्ट्रीब्यूशन को यदि आप कहें कि कोई एक सेंट्रल वैल्यू बताइए जहां पे सबसे ज्यादा एज कंसंट्रेटेड है, सबसे ज्यादा एज की वैल्यू है, तो उसी को हम लोग मेजर ऑफ सेंट्रल टेंडेंसी कहते हैं। से फॉर एग्जांपल अर्थमेटिक मीन इज अ मेजर ऑफ सेंट्रल टेंडेंसी, उसी तरह से मीडियन इज अ मेजर ऑफ सेंट्रल टेंडेंसी, मोड इज अ मेजर ऑफ सेंट्रल टेंडेंसी, हार्मोनिक मीन ये एक तरह से पूरे डेटा का एक रिप्रेजेंटेटिव पॉइंट है जिसको हम सेंट्रल टेंडेंसी कहते हैं। और उसके बाद जो नेक्स्ट पॉइंट में डिस्कस करने जा रहा हूं, दैट इज रिक्विजिट ऑफ आइडियल मेजर ऑफ सेंट्रल टेंडेंसी, व्हिच मेजर ऑफ सेंट्रल टेंडेंसी शुड वी यूज, and what can be an ideal measure of central tendency, and what are properties of ideal measure of central tendency, which characteristics a ideal measure of central tendency should possess। तो ये चीज जो है वो हम डिस्कस करने जा रहे हैं, रिक्विजिट फॉर एन आइडियल मेजर ऑफ सेंट्रल टेंडेंसी। Is it clear now?
Yes, sir.
For an ideal measure of so what are the requisite? We will discuss few points. So the first point is it should be rigidly defined. The second point is it should be comprehensible and easy to calculate. Third point is it should be based on all the observations. Fourth point is it should be suitable for further mathematical treatment. So, what is its meaning? Its meaning is suppose you have given the average of one series, say x1 bar, and other series x2 bar. So, it should be suitable of further mathematical treatment with by using x1 and by using the average of first series and average of second series, you can calculate the average of overall both series. So it should be suitable for further mathematical treatment. This is the meaning of this point, that you can calculate the average of composite series by using the average of two or more series. The fifth point being it should be affected little or as little as possible by fluctuations in sampling. It should be affected as little as possible by fluctuations in sampling. Means what is meaning of this? Suppose there is a population.
सर लास्ट में वर्ड क्या है वो?
Fluctuations
फ्लक्चुएशन के बाद
in sampling. Okay. Sampling. Okay, so what is suppose we have a population, and population means the entire a collection of you can say collection of some characteristics, and what we can collection of, you can say a population as collection of individuals. individual or items. Okay, and to infer about population characteristics, say for example, collection of you can say collection of height of peoples in Varanasi. Okay, so it is a kind of population, but what we usually do, we do not measure each of the each person's height in Varanasi. So what we do, we draw a sample. This is a sample. So what we do, we draw a sample of from Varanasi and calculate the average height, and based on this average, we infer the characteristics of population. So basically, what we do, we draw a sample from population and measure the characteristics of sample, and we infer about the population. Okay, so there may be a number of possible sample from population. Okay, you can draw so many samples from population. Okay, so say for example, there are two ways, with replacement and without replacement, but I'll not go to that. But just I want to say that you can draw a number of samples from population, and the average should vary. The variation and in average should be as small as possible. Okay, so variation in average in it should be as small as possible from sample to sample. So this is basically meaning of this point. So suppose I draw this sample, say this is x1 bar. Then I draw another sample, say this is average is x2 bar. And I have drawn some other sample, say this is x3 bar. So we should select such an average that variation in x1 bar, x2 bar, and x3 bar should be as small as possible. Okay, so this variation should be very small, means this should be approximately equal. Okay, so we should select this type of average. The next point is, it should not be affected much by extreme value. Okay, so what is meaning of this? So I'm giving an example. suppose I have observation 2, 3, 4, 7, 9, 10,000. So most 1,000. So most of the observations are in unit digit. One observation, which is extreme observation, is in 3 digit. When we wish to calculate average mean of this, what will be the mean? 9 plus 9, 18 plus 7, 25, 1025. And what is average? 1025 divided by 6. If we calculate median, what is the median? Median will be 4 plus 7 divided by 2. So it is 5.5. Okay, and mean is something equal to
70.
170 point something. So which
Yes.
which is the true representative of this data, mean or median? Can you tell me which is true representative of this set of observations?
Median.
Yeah. So this is basically the point, that your average should be less affected by extreme values. Okay, so this is one characteristics of one requisite of ideal measure of central tendency. But mean it doesn't mean that we should not consider mean as an average, because mean has several other good properties. Obviously mean doesn't carry this requisite, but it has other several good properties. For example, it is suitable for mathematical treatment. It is suitable for further mathematical treatment. And we will see how it is suitable for further mathematical treatment. So let us start with first method, first measure of central tendency, which is arithmetic mean. Okay. So what is arithmetic mean? So we denote it by AM of a set of observation is their sum divided by total number of observations. And let x1 bar, x1, x2, xn are set of n observations. AM is equal to x bar is equal to 1 by summation I varying from 1 to n xi. Next is, in case of frequency distribution, suppose you have an observation like 1 3 times, 2, say for example 4 times, 5 2 times, 6 1 time, 7 3 times. So what we do, we write this these observation in terms of frequency. Say for example, x is equal to 1, f is equal to 3, x is equal to 2, f is equal to 4, x is equal to 5, f is equal to 2, x is equal to 6, f is equal to 1. Okay, and say x is equal to 7, f is equal to 3. So we denote it by xi and fi. So we represent this kind of data is known as frequency distribution. Frequency distribution. And what we do, we denote this by x1, f1, x2, f2, x3, f3, xn, fn. And for arithmetic of this kind of data, arithmetic mean of frequency distribution can be given as and this summation of fi is also denoted by capital N. Okay. Next, this is called frequency distribution. Remember this thing. When some observation are very frequent, we represent whole data in forms of frequency distribution, because in this observation, say for example 1, 2, 5 and 7 are very frequent. So we denote this type of observation by a frequency distribution. Next is grouped data. Okay. What is grouped data? Say for example, we have observation 0 to, we have data in forms of this 0 to 10, 10 to 20, 20 to 30, 30 to 40. In this way, you say we have and number of we have marks and number of students, and say this we denote this by frequency. Say for example, okay, in this case what we do, we take x as midpoint of this interval 5, 15, 25 and this is 35. So what we do, we take midpoint of interval. To write note that in
फास्ट कलम का
case
वो
of
हेडिंग क्या है?
क्या
फास्ट कलम का वो हेडिंग में क्या है वो?
ग्रुप मार्क्स है,
ओके ओके
मार्क्स है एंड नंबर ऑफ स्टूडेंट्स है. Okay, and we denote this by frequency. This is marks, this is number of student, and this is midpoint. Okay, we consider this as mid value as x. And what is mid value? This is upper limit. I am writing mid value is equal to upper limit plus lower limit divided by 2. So it is 5. Okay, this is upper limit, this is lower limit. Similarly, in this interval, this is upper limit, this is lower limit. So write a note. In case of grouped or continuous frequency distribution. X is taken as mid value of corresponding class. X is taken as mid value of X is taken as mid value of corresponding class. Next thing is you can so your homework is calculate the mean of this data. So calculate mean of this data. Okay. Next is if the value of X and F are large, X and F are large, the calculation of mean is time consuming. The calculation can be reduced by a great extent by taking deviation of given values from any arbitrary points A. Okay, how we do it? How we do it? Suppose we have xi, I varying from 1 to n. Okay, and fi, I varying from where I is equal to 1 to n. Okay, we have data in form of fin. What we do, we take an arbitrary point A and we calculate xi minus A is equal to di. This is an arbitrary point A and we calculate di is equal to xi minus A. And what we next calculate? fi di fi xi minus A, and this implies fi di is equal to fi xi minus fi A. Now taking summation over I fi di, yes,
जो ए आएंगे वो आईवीटी पॉइंट 1 से n के बीच में आएंगे.
नहीं, कोई भी आर्बिट्रेरी पॉइंट हो सकते हैं। ये आपको अपने ये इस तरह से लेना है कि ये कैलकुलेशन को इजी करा दे। सपोज आपका ऑब्जर्वेशन से फॉर एग्जांपल योर ऑब्जर्वेशन इज 1001, 1025, 1000 से फॉर एग्जांपल 15। तो ये कैलकुलेशन आपको टीडीएस हो सकता है। तो आप आर्बिट्रेरी पॉइंट यू कैन कंसीडर ए इज इक्वल टू 1000। तो डी ये एक्स आई सपोज करो है और ए इज इक्वल टू 1000 आपने ले लिया, तो डी आपका रिड्यूस होके क्या हो जाएगा 1 2 125 15। ये वैल्यूज काफी छोटी हो जाएंगी और ये फिर कैलकुलेशन आपका इजी हो जाएगा। इसको बस कैलकुलेशन को इजी करने के लिए किया गया है।
ओके
तो ये आपको अपने विवेक से लेना है कि आपका कैलकुलेशन आप इजी हो जाए। Okay, so now fi xi minus since a is constant, you can write this as a into fi. Okay, so as you know that summation of fi is equal to capital N, so it become fi di divided by capital N is equal to fi xi divided by capital N, and this is summation over I minus A, because A is summation of fi is equal to N. So you can write as summation of fi is equal to N, and this implies summation of fi xi by N is equal to x bar, and you can write a this side x bar is equal to a plus summation of fi di divided by capital N and summation over I. So this basically make your calculation easy. Okay. Now you can next what you can do to make your calculation easy, you can consider di is equal to xi minus a divided by h. So what it do, it takes deviation as well as it do the scaling. Okay. 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 So now what in case of di is equal to xi minus a, what you can do, fi di is equal to fi xi minus fi a, and this whole divided by h. Okay, and it will become, and if you take summation, it will become summation of fi di is equal to summation of fi xi by h minus n times a by h. Okay, and what you can do, you can take summation of fi di upon n h times, you can take h this side is equal plus A is equal to summation of Fi xi upon n. And this further can be written as x bar is equal to a plus on n Fi d. Okay, so this is basically your x bar. So what you are doing in first case, you are changing the origin. Okay, and in this case you are changing origin as well as scale. Okay, and with help of this formula, what you can do, you can your homework is calculate arithmetic mean. With help of this formula you have to do calculate the arithmetic mean of 0 to 1, 8, 8 to 16, 16 to 24, 24 to 32, 32 to 40, 40 to 48, and your frequency is 7, 15, 24, 16, 7, 8. So this is class interval, and this is basically frequency. So you have to find midpoint and then f, then find d is equal to xi minus a divided by h, and then you have to find d. I'm suggesting you take a is equal to 28 and h is equal to say for example 8. Okay, I'm suggesting you this and solve this problem. Now I'm writing one property before ending this class, and you have to prove this property of your own in next
सर
class.
स्लाइड ऊपर करिएगा थोड़ा तो.
Okay, and this property is sum of the deviation of a set of values from their arithmetic mean is 0. In other words, we can say if xi given fi I varying from 1 to n is the frequency distribution then I varying from 1 to n fi xi minus x bar is equal to 0. So the proof is so your homework is proof of this property. So proof is your homework. Okay, so you have to do 3 homework in next class. First, prove this property. Second one is this one, and earlier I have given one more homework. Calculate the mean of this set of observation. So this was also a homework. Okay, so I'm stopping here. I'll discuss rest of the things in next class. I may take one class in tomorrow first half. Okay.
Okay,
So,
sir.
कब सर?
Okay, sir. Thank you, sir.
Thank you, sir. Thank you, sir.